This is normally a user group talk, so it's expected to be about an hour and stuff, so we're very, very hard on time. Instantaneous monitoring. You guys already figured out I'm working for Instana, so who can find the Instana in the title, you're good to go, you can keep it. Anyways, the real title of the talk is a little bit different, right? It's more like, have you ever had the feeling you wanted to monitor something, but you forgot to configure it up front? That's not as catchy, right? That's the problem. So I stayed away from putting this into the official title, but that is what we're going to look into today. But first of all, we have to play a slightly little game here. Because all my talks are interactive, and I said this is a user group talk, but normally, so that has to be extremely interactive. Interactive normally means for me, when I'm doing some live coding, I do mistakes, and you tell me, hey, this is actually wrong. Oh, come on. This is actually wrong, like now, right? Something just crashed, and I don't care. But for this time, we're not doing some live coding, but we have some stuff afterwards, and I need your interactive help for that, to make it happen. So that was after a talk in Brazil, and that is what the people looked like, right? They were like totally engaged, and they were all like, yes! And they wanted to dance, and we're going to try this. So everyone stands up and starts dancing now. Thank you. At least some people always do it. That's good. At least some people. But anyway, so real thing, development pipeline. Who is the developer? It was most of you, right? Most were Java, some other weird language. OK, perfect. So most of the people are Java. What do we do in Java these days? We build modular applications. And I'm not talking about Jigsaw stuff, anything like that, but modular most of the time in the sense of microservices. How many are still working on legacy, like monolith applications? Oh, you poor people. Right? But who works still on a monolith, but the company wants to move forward to a microservice environment? OK, that's a few less, but it's still enough. So you know what I'm talking about, right? We're trying to figure out how this stuff works. So microservices are like the new cool thing. Unfortunately, I have to take this away from you. Everyone claims how easy microservices are and that they are like the solution to everything. It's not true. Believe me, it's just not true. Don't listen to anyone else. Continuous integration. Like you commit something and you have a whole set of stuff running right behind it, like integration tests, unit tests, all this kind of stuff. Who does continuous integration? And please, every hand up. Oh, come on. Seriously? OK, for the people who do continuous integration, how many do continuous delivery? Oh, that's actually a quite good number. How many deployments per day? 100? 50? 20? 1? Well, you understand that's not continuous deployment, right? OK, anyways. So a little bit about me. I just go with Chris. My official name is Christoph, but that doesn't work in countries like Japan. I was like, Christoph? I was like, Chris. Chris is good enough. I'm working at Instana. I was at Hazecast before, so it was half correct. It seems like it was some old bio, maybe. I'm doing developer advocacy, which means I'm doing exactly my job right now. I'm flying around the world, talking at conferences, writing white papers, telling people how awesome technology, how awesome monitoring is, and especially, and that's interesting, I am supposed to talk to developers. So we're in a good spot here, right? Developers normally don't care about monitoring. It's a little bit like with databases. You have the DBAs, and the developers are like, databases, I don't know, right? The same goes for monitoring. Like, no, I committed. Go away with all the crappy shit after that, right? I don't care. I'm a pretty big Java passionate. I'm a Java champion. I haven't done any real Java coding in like the last 2 years. I'm doing all kind of crazy stuff, but we'll see that in a minute. And most of the time, I'm all into performance stuff. My personal favorite is performance fairy tales. I mean, who really believes NVIDIA is faster than AMD? Or who believes AMD is faster than NVIDIA, right? It's just what you measure. So measurements, and I'm sorry, performance measurements are really bad. But because that picture is like, yeah, that was my wedding picture, I like it, but for a technical conference, I had the feeling I have to give a little bit more of a technical introduction. So that's me, and I think all of you know that movie. That was the closest picture I can find to me, or what I am. And I have a couple of languages that I really like. As I said, I haven't done too much Java in the last couple of years, but I'm really big in the Kotlin community. I'm actually running the Kotlin user group in Düsseldorf, so if you ever come by, happy to have you. Doing a lot of TypeScript these days. Unfortunately, doing a lot of Go. Well, unfortunately in like brackets. There's a couple of languages that I totally don't like. Right? I often say there's 3 bad Ps. It's Perl, Python, and PHP. And obviously I'm German, so what else, right? I love beer. Okay, so that's like the most technical introduction I can give about me. Anyway, going back to what we're actually looking at. Typical applications these days, right? So who uses more than one programming language? Oh, there you go. Right? How many, or who has more programming languages or more than one programming language in production? You see? We're heading there, right? So, and that is a trend that is very important to follow, just for the reason that we're not at this like one language shop anymore, right? It's not like we're like, yeah, we're just doing Java, we're just doing, well, Nodejs. We're not just doing Python or anything like that anymore. It's not gonna happen. We have the chance, or we're in time where we have the chance to choose the best tool for the job. And if it's .NET, I'm sorry to the 2 guys we were just talking to, if it's .NET, well, that's okay. If that's the best tool you can think of, fair enough, right? I know, that was a little bit mean. I mean, there's worse languages like Python. There's always a worse language. But we have the chance to take the right tool. And Python, for example, is really big in the machine learning environment, right? So why not go for Python? Why use anything else? So that's the first big trend we see these days. The second thing is databases. And, well, just for the laughs, because we started with the Oracle database. Obviously, a lot of companies still have this like beefy servers, like massive, always a little bit more expensive, a little bit bigger. It could be Oracle, IBM, SAP, whatever, right? You name it. There is still those things, and we're not going to get away with those in the next couple of years. But same thing, we have the chance these days to change our environments to actually take the best technology for a specific job. With microservices, it's even easier, right? A microservice could use a completely different database from anything else in the system, anything else we run. In the past, when you talk to operations, it was always like, yeah, you know, we don't have expertise in running this, but with containers, it becomes much, much easier these days. So I totally encourage you, if you're running a microservice environment, or if you're heading towards it, try to take the best database for a specific task. And if you run 5 or 6 databases, that's completely okay. It's nothing that keeps you away. If you're running a time series calculation, take a time series database, right? Those kinds of things. It's really important to make sure of that. And the third thing, we're talking about microservices, obviously there's Docker, right? And there's a lot of technologies that we can use these days to actually deploy our application. Most of them, for better or worse, whatever, use Kubernetes. That's just an accident that is in the middle. But Kubernetes is like the most common framework these days. Pretty much every cloud vendor or cloud hoster offers a Kubernetes cloud. You also have Cloud Foundry or whatever you want to use. In the end, you end up building a Docker container, you deploy it somewhere, and you're good to go. That's the whole idea behind it, making deployment easy, making scalability easy, right? Same thing, if you use AWS, you also have the chance, we just had the serverless talk, right? You can also go for serverless, all this kind of stuff. But same thing, you have a lot of technologies here, and choose whatever you think is the best for your application. We have the chance. So it's the first time in engineering that we can take whatever we think is best for our application. But, as I said, well, microservices are not making it easier, right? There's a lot of independent services. Most of the time, they're written by independent teams. Independent teams means, well, you have some interface specification, and you hope that everyone agrees on that. It works. The people who write microservices, who have this issue with inter-team communication before, right? Everyone's writing these like, yeah, we've written this microservice and we changed it a little bit. And now you have this problem again where you have to make sure that you're in a release train, right? They change something, and either they are not backward compatible, so you have to do it as well, and you have to release at the same time, or you have this problem where you have to support multiple versions to make sure that you can deploy independently. So it's not all like awesome, but we have the chance to split up the services into smaller chunks and distribute them in different teams. So that's a good and a bad thing. And then is the real problem, right? We have this like very well-oiled machine, a lot of independent services, and yes, they would actually all turn. I'm pretty sure about that. And you have like the user, which is the gear on the top, which actually spins the whole machine, right? So we're trying to answer a user request here. What is easy to figure out when you have such a distributed system is when something completely fails, right? This gear is gone now, the service is dead, nothing will work because that's like your entrance point to all of the calculations. So that's easy to find. In the worst case, your customers complain, hey, nothing's working. Your application is shit, right? You don't want that, so you try to fix it up front before a customer figures it out, but it happens. So you get this domino effect, right? Service failure always has domino effect. Something fails, at least in a microservice environment, something fails and everything else fails with it, or at least to a certain extent. What is actually harder to find, and we're looking back at this thing, and I'm going to jump back and forth between the two slides a few times so everyone can actually figure out what's going on, right? You see it? What is that? You can just scream to me. What is that? You haven't figured it out yet? Oh, let me tell you. It's a service slowdown, right? So nothing really fails here, but now we have a slowdown, which only happens once in a while. And that is something that is really hard. Who knows this feeling? You get a message from operation. Sometimes your service is shit. Sometimes the response time is really bad, right? And you're like supposed to figure it out. Like, yeah, what means sometimes? What is sometimes? How often does it happen? What does bad mean? What is a bad latency? You just have no idea. Or even worse, and I like this, and I'm pretty sure everyone knows this bug report, nothing works. Right? What does that mean? What is nothing? Nothing works. I love that. So that is the hard thing to figure out, especially in microservice environments. In a monolith, it's okay. We can go and take a profiler, attach it to the service, and we're probably good to go. Right? We're only having one programming language. You attach it to a profiler, and you're good. Here we have, I don't know, 20 services. And let's imagine they are written in 10 different languages using different technologies, whatever. How do you figure out what is going on, what is happening, right? That's a really big issue. It's not as easy anymore. I told you, microservices are not the glory solution that we just have, right? So what you actually need is something which we call continuous monitoring. You remember continuous integration, continuous deployment. Now you need continuous monitoring. Continuous monitoring for us means here is your application, here is your services. Somehow the services are part of the application, and now you want to figure out how they interact, what is happening, how the system behaves. So continuous monitoring also means that when you deploy, you want to make sure that you understand that, okay, now is something happening, right? You don't want this information in an hour or two from now. You actually want this information in real time. You deploy and you want to know that something went wrong, the new version is behaving badly, something like that. So how do we do that? Well, that's what commonly is called distributed tracing. Who uses some distributed who heard of distributed tracing before? Okay, I think I can just skip the question who uses some distributed tracing framework right now, because it's probably the same people or even less. So distributed tracing is the technology that, and I go with the same term, a transaction, but not in a database sense. A transaction is, for me, a user request response story, for example, for a web request. You get a web request from the user, you go through a lot of different systems, including databases maybe, and then you go all the stack up again and send the response back to the user. So that is what we call a distributed trace or a user transaction. So distributed trace basically looks like that. So you have the client, which sends a request to some kind of front-end service. We call it service 1 because I'm so extremely creative. And the service 1 calls a couple of back-end services to fulfill this user request. As a distributed trace, it looks like we have a whole span, which is span 1, which is service 1, because service 1 actually is still running while it's waiting for the responses of service 2 and 3, right? And like in a stack trace, pretty much, you see how the service runtimes aggregate to each other and which service actually called what. We see this in a little bit, in a bit more of an interactive fashion. So is that clear? A distributed trace is pretty much a stack trace, but instead of going through source code, you're going through the different services. I think that's clear enough, right? You remember I said interactive, so yes. Perfect. Very good. So now we have this like distributed trace, and we see how the services work together and how the request flow is. Okay, so how can we present that? I mean, you guys really want to understand how this works, right? And how this would work with the application. So who likes coffee? And still not all hands. What would I have to put up if it's not coffee? Beer? Let's see. Oh, okay, fair enough. So imagine it to be a brewery. Very good. So coffee. Everyone likes coffee. And I saw this in the room. It was everyone. Everyone likes coffee. So let's build a coffee machine or an espresso machine. And who built an espresso machine made out of microservices so far? Nobody except me. That's weird. I thought that's like a common hello world example for microservices. Anyway, so we're talking about microservices here, right? So why would we go for a single espresso machine or a single brewer? We're actually going for full scale, right? Nobody needs a single espresso machine. We're like, cool, parallelism rules. We're going full scale. So as I said, I built an espresso machine, which consists of a couple of microservices and some external services, which normally come from the crappy old company that we don't want to work for, but we have to use their services, right? So let's start with those. We have a temper service. These guys actually did a good deal. They only have a single use case for the service, so that's good. That's pressure as a service, and we all know that, right? Pressure as a service is a thing. Everything is as a service these days. So these guys are the good ones, but the ones on the bottom, they're like the really bad ones. They actually have a multi-tier layer application, classical monolith, something like that, right? So you have the storage layer and the middle layer in the same application. Really bad design. We all know this. If it's a legacy app, we want to go away with that, but we have to use it. Anyway, we have a front-end service, which is the front-end itself plus the one that takes the request from the user front end. And he sends it off to the coordinator service. And because I like robots and a coordinator is something that manages all the stuff, I thought that's a good metaphor. So we have the now robot. He's our coordinator service. He gets a request to brew something, and he knows, okay, to brew something, I need some coffee powder, so I have to go to the coffee grinder service, which is external. Afterwards, I need to send this powder to the temper service to get a nice tamped system or nice tamped coffee powder. And then I go off to the brewing kettle service, which does the actual brewing. But obviously, to brew something, we also need water. So he needs to go to the dispenser service. That's a classical espresso machine application design, isn't it? I'm pretty sure everyone writes exactly that way on a microcontroller system. Okay. So, right, because we're cool kids, we're going to deploy all this, or actually, I already deployed it because we're short on time. So I already deployed all of that into Kubernetes. Kubernetes is cool, right? Kubernetes is cool? Oh, Google doesn't like that. Okay, so who worked with Kubernetes before? Okay? Who thinks Kubernetes is a very simple solution? Oh, only one person. Yeah, after that picture, you shouldn't believe that. So you have at least like 10 to 20 services just to make Kubernetes run in itself. Right? You have the ingress service, you have a couple of services to actually manage the cluster, you have the kubelets, you have the proxies, all this kind of stuff. Kubernetes is not an easy system. It's not the magic black box that solves all your issues. Be aware of that. And there's one bigger issue with Kubernetes. And I'm pretty sure everyone agrees on that. And if there's only a single person in the room who likes that, I'm sorry, there's the door, right? It's YAML. It's like the worst idea ever. Like, why? I mean, who likes Python? Okay, take your hands down. Who likes Python? Take your hands down. A language which uses white spaces as syntax is a shitty idea. Believe me, it's a very crappy idea. A configuration language using white spaces doesn't make things better. It's just a stupid idea, and it's not easier. Well, it's probably easier than JSON or XML. I agree with that, but it's not a good solution. Anyway, so demo. And because I need all of your help, you remember interactive? We talked about interactive here. So we want to create some stack traces, some distributed traces, sorry, not stack traces, but also some distributed traces. So how do we do that? I actually deployed it for you. So everyone can go ahead and use it right now. So it's bit.ly instana-o-presso. And everyone's gonna open it up on his mobile phone and trying to get some coffee right now. And I deployed it into Google Cloud, so it should actually work. It should not fail. Let's see. And after that, I show you a little bit of stuff. So just for the sake that you know what's going on, we have this amazing espresso machine, and you see there's at least 2 people, 3 people using it right now. 4 people, they're very good, and I can't do espresso right now. So in the end, if there's the espresso, click on it, right? Click on the espresso. Oh, there you go. Okay, so while you are going on and doing some espresso machine stuff, I'm going to show a little bit of stuff here. So as I said, I'm working for Instana. So to make this talk worthwhile for my employer, I had to do a little bit, right? We're not just brewing coffee here. So for Instana, the main idea is we try to make monitoring, and you remember continuous monitoring, we try to make monitoring as simple and as automatic as possible. And we try to give you all the information you would normally forget to configure before you know you need them. So for Node.js, and you remember I hate JavaScript, but I have to go with that first, there's a little bit of stuff to do. With Go, it's a little bit more. With Node.js, it's literally just that. You, in the first file of your application, you go ahead and say, hey, please add the Instana sensor to my application. And from that point on, Instana will will look into your application, and will find all the important points and instrument them on the fly. So no changes to your application except for adding one line, and if you want to be really cool, you also say report uncaught exception, because we don't do this by default. But while I was writing that, because I hate because I hate JavaScript, I was too stupid to make it run. So uncaught exceptions were like really nice to see them in the system. So that's Node.js, and I think everyone can agree that's good enough for most systems. But most of you guys are Java developers, so I actually have one Java application, which is a Spring Boot application. Who uses Spring Boot, by the way? Very good. You know that Josh is coming later on, and he's showing you all about Spring Boot. You're going to love it. He's a fantastic speaker. So Spring Boot, a very simple application. It does a lot of stuff. That's actually the water service, the dispenser service. You remember that? And the dispenser service gets the request and says, well, you know, I'm gonna wait for 400 milliseconds because I need to figure out if there is water actually. That's a very time-intensive application or a very time-intensive calculation. And then we just say about 30% of the time we return false, and the other time we return true. And if we get false, the service that actually called the dispenser service has to wait a little bit longer because the dispenser service has to be refilled and tells you the water afterwards, right? So yeah, whatever. It's just an application, right? So okay, we're back here. So what actually happened in the background? Well, the services got executed, and whoops, wrong, there you go. And that is Instana. Instana is actually a monitoring tool which combines infrastructure and application monitoring, application performance monitoring, sorry. So here's our Instana cluster, or our Instana Presso cluster. You see, it's 3 nodes. We can actually see, as I said, I deployed this on Google Cloud, so we should see that there is, where is it? There's a GCE instance. It's a standard, so you get all those information. And nothing here really needs to be configured, right? So that's everything that Instana figures out by itself. And it figures out, hey, you're actually running a Kubernetes cluster, that's your cluster name, blah, blah, blah. Good. As a Kubernetes cluster, we hopefully have some Docker containers running. In the future, it will be more like cryo or stuff like that, in case you're a little bit deeper into Kubernetes. But for now, imagine every container in Kubernetes is a Docker container. So we should actually see something. And there's a couple of things. You remember there's the kube proxy, which makes sure that I can actually do some networking in my application. There is the Instana agent, which is interesting. The Instana agent is the stuff that we deploy into the Kubernetes cluster. For Google Cloud, it's actually really easy. You go to the marketplace and say, hey, I want to have Instana in my Kubernetes cluster. So Google sets up all of that, and that's basically the only thing you have to do, right? So you install the Instana agent once, and everything else works automatically. And I say automatically because that's the real term for it. The way it works is the Instana agent has access to the Docker socket. That means we get a notification every time you start a container or you stop a container, and we know exactly what's going on, so we keep this continuous monitoring. We automatically keep up to date, right? We walk into the container, we figure out your technology stack, what is actually running in terms of the JVM. Oh, right, in terms of the JVM, I forgot to say that. You see there's no change. That's a standard Spring Boot application. We actually had to configure nothing, and that's like the beauty about Instana for not only Java, but also PHP and a couple of other things, all the stuff I really don't like. But we don't have to change something. So we can go into Java on the fly and say, OK, we understand what technology stack is running. In this case, it's Spring Boot. So tell me what to do. And here we have our Spring Boot app, for example. So it figured out you're actually running 4 Node.js applications. And you remember there's a couple of different services. And it also figured out there's a Spring Boot app. The interesting thing is if we click on the Spring Boot app, where you go, there you go. So it figured out, hey, there is a host, which in this case is the the virtual physical host, the GCE instance. That one is running Docker in some way. Inside of the Docker container, there's a Java process. Obviously, a Java process is a JVM. And inside of the JVM, they run Spring Boot. You remember, no changes at all, right? It's just what the system figures out automatically. And the interesting thing is we can click on all of those and say, hey, please give me a dashboard for that. Right? So you don't have to configure anything. Really cool. And it gives you all the important information, especially stuff you normally, well, maybe you configure like a heap memory, but who configures the actual memory pools, right? Any monitoring system that has the memory pools by default? No, right? But we try to capture as much information as possible. So let's go into the application itself. For that, we have a little bit of a different perspective. Where is it? Let's see. Oh, where is my application? It's not here. What? Somebody cleaned it up. Oh, no, there's next. Let's see. I don't think any one of my colleagues actually cleans up. Nobody cleans up after anyone, right? Why would we? That's the reason why we have temporary workarounds years after. But I think they actually did. Why did they do that? Oh, OK. Let's go ahead and create an application perspective. We call it Instana Presso just because. Whoops. And we want to use, what is it, Kubernetes cluster name equals Instana oppressor. There you go. And yes, save all of that. There you go, live coding. Well, kind of. So, what did we do? We created an application, and we said, please add everything from this Kubernetes namespace into my application. That means we actually have a couple of services, and, well, it doesn't show the services right now. So if somebody could go ahead and add some more coffee to it, that would be cool. Oh, you're still doing it? Yeah. OK, so it should show up in a second or so. So what happens is Instana now figures out, OK, there is this service request, and it automatically figures out, OK, this is the flow of the services. So that means all of those services are actually part of the dependency tree of my requests, which is really cool, right? So what we figure out is, OK, there is this services, and you see their coordinator service, the grinder service, and all this kind of stuff. And they also have different types. They could be a RabbitMQ, it could be Nodejs. There should show up a Spring Boot application in a short while. I'm just trying to reload it over and over again. Well, it's going to happen right now, obviously. But the other interesting thing is, I said it's trying to figure out what's actually going on. So that's what it's doing, right? So you see there is the front-end service, and there is a messaging service or message queue events. And you see exactly how those services work to each other, right? So the event queue is actually getting information from the coordinator service while the coffee is being brewed. For the people who haven't seen it, I'm not sure if I can actually make it happen right now, so you at least saw it once. Let me see. I can try to unblock, well, whatever, number 4, for example. And someone is faster than me, obviously. Hey. There you go. So now it's making my espresso in the background. The service is being kicked off. It's actually doing the brewing, blah, 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 all this kind of stuff. And in the end, you get this nice espresso, right? So that's how it works. And while it is doing that, it's constantly analyzing the system. So it automatically figures out how the dependencies work with each other. And that is an interesting point. Who in the past, and I'm pretty sure everyone, who in the past started with a new company and tried to figure out a system? Right. How many of you had to actually figure out a system of microservices being written by multiple teams trying to understand the system? A system which is only basically documented. I mean, who writes documentation, right? And it's not like I'm different. I don't like documentation, but you sometimes have to. And in this case, someone new comes in your company, and imagine it's a service which needs a couple of more services, or it's a request flow that needs a couple of more services. The person looks at that. It can click itself through all the different services, trying to figure out what's going on. It's really nice and really easy to understand for the person. The interesting thing is you see these little dots flying around. Those are actual requests going through the system. And now it relayed it. OK, fair enough. Let's see if we get our Spring Boot service now. Still not, for whatever reason. I don't know. Live demos. Yay! Anyway, so we see we had a couple of requests, which is good. Wow, 82. Is that the number of people in the room? So let's go for the next cool thing. So we were talking about distributed traces before, right? So you already see there is unblock. OK, fair enough. But there's our machine. Or let's go for the other one first. So there's a root request. And the root request, well, gives you the front end, obviously. So that is very simple. And you already see there's a distributed graph, which only has one stack frame, obviously, because it only goes into the front end service. It returns the HTML, and you're good to go. OK, so from that, we're jumping a little bit back. And we say, they removed everything. Why did they do this? Oh, come on. OK, it's probably not going to work now. Let's try it. That's the situation when you like your colleagues, right? They're like, yeah. OK, so it probably got a new key ID, which is bad. Okay, it's probably not going to work. So let's go for another application. Let's see if we can find something. Let's actually use that instance for a second. Oh, come on. Because that's our demo environment, so I definitely know there's something. So we have our shop, and you see exactly where your users are coming from. You see what happened in terms of JavaScript errors. And you remember JavaScript only has errors. I never said that, right? And you see the first stack, or the first, loading stack. And that one is actually a web shop page. So it uses a couple of more application things. But what is interesting, you see the view backend trace. And that's a very important thing about Instana, that we have every single request that ever went through the system in the last year. That means we can tell you exactly that user who opened the website had that request. And it not only works for the initial page load, but it also works for AJAX requests, right? So it actually, whenever you have a single page application, it will add all the requests going for this specific session for that page, which is really nice because you can see exactly what was the user journey for a specific person. And you see that is a little bit more of a complicated thing. So we have the English shop. The English shop goes down to the real service, which handles all the languages. And that one does a product search. And in the end, it does some other get, a product service get. And we see some other things. So we actually see all the actual timings for the services itself. But we are developers, that's nice, but that's not what we're looking for. So what we are looking for is something that looks like stack traces, something we know. Especially as Java developers, we love stack traces, don't we? Java developers love stack traces. Do I need to do the Steve Ballmer's stack traces? No, okay. So that looks like a stack trace. It shows you exactly the service calls going through the system, having all the things in order and indented or with indentation the way we expected. And we can also click on all this stuff. So for example, we can see, let me do this a little bit bigger. Okay, here's our caller details, right? So we called the request product search or the URL product search. We had some demo product AP parameter. That is the calling information, like, okay, that is what went back. And here is the really interesting thing, right? So you see exactly where this call happened. And remember, you don't have to configure anything for Java. We just figure it out because we understand the technology you're using. OK, let's try to get back here. So, well, no, fair enough. Let's use our, there you go. There's the espresso machine. I just called it differently, so it was all my fault. OK, fair enough. Analyze traces, same thing. We go to the coffee machine, and we actually can see all the requests that were going through the system. That was a bad one. Let's see, where's one that actually does a little bit more? It's espresso. Espresso, I think, is the coordinator service call. Yeah, so that one. So that actually does quite a lot. And we see all those little green bars. And the green bars, so as I said, that's like the view for non-technical people, right? But as developers, we want to understand a little bit more. So if we go down, we actually see, OK, all the little green bars, there are messaging requests, either sending something to the message queue or retrieving something from a message queue. The good thing is, with both views together, we understand where there is a gap. And we had this earlier this morning, this talk about, well, how do we try to blame the operations team in terms of network applications, right? As developers, we are always at fault because our services are always the bad person, right? When you talk to somebody, it's always the developer, your service is shit, and you're trying to figure it out, and you can't figure it out because it's not your application, but the network latency. With this system, and looking into the actual calls, you can say, OK, this is what happened. Then this service sent it away at this specific time, and that is when it arrived at my service. Everything in between is not my fault. So that's the best thing for developers. You can actually prove it's not my fault. Very important thing. And we're going back to the demo service because I want to show a few more things, and we have 5.5 minutes, so one minute thing. So with Instana, we have two different things. Everyone knows issues or incidents, whatever people call it, right? So normally, that is what your incidents look like. You have a couple of different services, and you see the same message over and over again. And we can actually see those are independent or different services, and they all get the same problem, right? Error rate is too high. So normally, what happens? What is it? Like seven different problems. Operations would take those issues, get an alert on that. They are notified in the middle of the night, and they take those errors and send them to the independent people, right? So in this case, probably like 6, 7 different people, until everyone fix it. It's a problem that our monitoring system told us. Okay, fair enough. Because we understand how the infrastructure works in itself, and because we figured out how the dependencies between different services is, we can actually go ahead, well, that's a different one, but it doesn't matter, and say, okay, please show me, or please only notify me once for all those problems that are related. Related could mean it's dependent services. If you have a chain of 5 microservices and the last one fails, or the database fails, whatever it is, obviously the ones before that will fail too, or get some issues, get some timeouts, have to wait for timeouts, something like that. So you will suffer one way or the other. And what Instana does, because we understand how the system works together, we can actually aggregate the single issues into the independent issues into a single incident and tell you, okay, here is a sudden drop in number of requests because that was the last thing that was part of it, but there is a sudden increase, there's a sudden increase, there's a sudden increase. And then you see, okay, so some Elasticsearch node actually went red. So it failed for some reason. The JVM crashed, whatever, maybe the node was restarted. But at a single glance, you see exactly the problem and the problem statement. And now, well, operations might still don't really get it. I hope there's no operations people in the room, but most of the time they don't get it, which is fair enough. So they would go ahead and tell the same 6 people, hey, this is your issues. And they go ahead and they take the link and send it to via Slack or whatever, and you open it up and it shows exactly the same page, the same thing he looked at, and you're like, oh, yeah, that's the Elasticsearch guys. Let's hit them. And they probably get like 6 different requests because they didn't get the first one, but now they get 6 from the developers, and they're going to fix it for you. So Instana, from my perspective, from the view of developers, is all about moving a blame away from you. So developers should be interested in monitoring, especially when the monitoring tool helps you to understand what is really going on and to keep your app or your workforce on what is the workforce supposed to be, which is developing new features, fixing real bugs, not looking into a system for an hour trying to figure out that you're not at fault, right? So that's the important thing. And with that, questions? Yes. I think we had a microphone, right? Yes, perfect. Two minutes. I think you went one too far.
Hello.
Hi.
Is there a way to track some kind of custom metrics?
Custom metrics, yes. There is a way. In this case, obviously, it's not automatic anymore. But there's a couple of ways to capture custom metrics. First of all, if you start at the website, you can actually add additional metadata to the first request, and that will be tracked through the system. If you want to have specific metrics or other metadata for a specific service, Instana supports open tracing, Jaeger, Zipkin, whatever you can think of. Just send all the information you want to the Instana agent, and we're going to add it to the backend. So as I said, we're trying to be as automatic as possible for all those kind of things.
Okay. Okay, vielen Dank.
She's coming.
Yeah. Is there possibility to integrate with for example, a traditional Jira issue tracking system, where an issue spotted on Instana could be propagated to the Jira, for example?
Sorry,
so to the issue tracking system, you know.
Oh, so you mean when you get an incident?
Yep.
Yes, so we have integrations like the most obvious ones. So you can actually send it to Slack, you can send it to whatever the Atlassian tool is that I forgot, and a couple of other things, but we also have a webhook service, so you can just hook in and to move the request or the issue to anything you like.
Thank you.
I think we're running out of time, and I don't want to keep you away from the lunch, except for there's another question. Here's one more. Okay, last question. I promise. I need to come here a little bit because...
I have a question, like how does Instana work with a proxy API if you have something in front like getCong or WSO2?
Yes.
Does Instana have insights in that zone? Or?
Good point. Proxies. Especially when you look at Kubernetes, there's Istio, which is becoming pretty big. And everyone tells you Istio, it's like, what is it called, service mesh? Service mesh, you're basically just talking to a local host, and the service mesh makes sure that your request is routed somewhere, you don't know where, and remember, you always have network traffic, and in the worst case, you have different data centers. So it's not the black box it should be. And yes, Instana supports Envoy, which is the underlying proxy service. We also support Nginx proxy. If there's anything you need which is not supported, feel free to contact us. It's normally fairly simple to get all this information. And when we get the information, it's easy to put it in a stack trace because we just need to pass through a couple of HTTP headers. OK, with that, thank you. Have a nice lunch. I'm around today, so if you have any questions, feel free.